Hello, good morning, everyone. Welcome to week 4. This is our live review session, our lab session for BIMM-143 here at UCSD. Thank you for joining us. I'm going to check in the comment section to make sure everyone can hear me and that we have no technical difficulties with the sound and the picture. So thanks for joining. Can I get a comment back for sound working? Thanks. Just to make sure I'm not talking to myself as usual. Okay, so I'm going to keep on plowing back, and we'll check on the comment section here to make sure that people can see what's going on and hear what's going on too. I'll pull up the slides here. So this morning, what I really wanted to focus on initially is a description of our project. This is our main project in this class. There'll be a couple of other smaller skill projects that we'll do kind of as lab exercises within a given week, but this one spans actually the entirety of the course from now on right to the end, as you'll see, and it's worth a big chunk of our grade. As you see, 20% here of your overall grade will be assigned based on this project. So Alina, thanks for the comment back. That's great that you can hear me and see me. Thanks for joining us. So the objective with this project assignment is that I want you to demonstrate your grasp of all the things that we've learned to date, plus the things that we're about to learn in the coming weeks. So that includes all those database searching strategies, those alignment approaches that we've been covering, sequence analysis that we'll delve into, some structure analysis, but also some coding with this R environment that we're going to start learning this week in class and throughout the rest of the class. So we're going to put all these things together and doing it in a more kind of project-based approach. It'll hopefully tie together lots of elements of the course so you can see the similarities and the commonalities and how they complement each other. So the idea here is that you'll create a report, and I've got links, of course, to all of this on our class website, including an example report for this quarter. You can see one that I've done that is filled in, that has example answers, and you're welcome to do any other gene out there in the universe apart from the one I use in the example report, because it's already been done for you. I use beta globin there, the thing that we covered right back in our first class, and I walk through all those steps. So you'll see an example of what a successful report looks like, see what success looks like there by checking that out. And we'll have a look at that in a moment together, and I'll walk you through some of it. Now there's two important points here at the bottom of the slide that I want to make sure you're aware of. That is that we've divided it up for this term, for this quarter, into two sections. I want you to, there's 10 questions in total, but I want you to answer questions 1 to 4 relatively quickly. So you see they're due May 5th, so 5th of the 5th, 2020 here, so there should be no ambiguity about it. And the reason for that is these first 4 questions, in ideal circumstances, they can be done pretty quickly, 30 minutes, 40 minutes max, something like that. You can do these first 4 questions and find a gene that's novel, something that we'll then explore in the following 6 questions and put some more meat on the bones, if you will. Now, I'm asking you to turn that in on May 5th because I want to give you feedback on it right away. I don't want you to do what can happen in these kind of online courses, is that there's a project to do, but you're busy with other things and you kind of put it off and you leave it to the last minute, and then you've got the entire thing to do all at the last minute, and you struggle with question 3 or question 4, and then you're kind of snookered. You're kind of like getting frustrated, and if you just give yourself more time, it would have been easy, right? So the only reason, and I'll stress this again, the only real reason for you not to get all the marks in this project and learn a great deal from it is that if you leave it to the last minute. And I know it's human nature, especially in these times, to put things off, and there's always other things to do and distract us. But I really want you to encourage you not to do that. I want you to kind of work on it consistently, little bit by little bit, especially the first 4 questions. So I'm requesting that you turn them in early on May 5th, which is following Tuesday, 2 weeks' time, and then we'll give you feedback. We'll give you a thumbs up and say in Gradescope, yeah, you're great, please continue. And then you have the entire rest of the quarter right until our last week to finish all the other questions. And you'll be happy and it'll be a weight off, okay? So don't leave it to the last minute. Now back or forward to June 5th and that final week, I want you to submit your entire report, your answers to all questions, all 10 questions, not just questions 5, 6, 7, 8, 9, 10. It'll actually only be fully graded at the end, so there'll be no points given to you on May 5th when you put in the first 4 points. You'll just get a thumbs up saying, yeah, looks great, or maybe think again and there's not enough here to give you full marks later on. So we'll give you that initial feedback, and the full thing will be graded right at the end, and we'll all get 20% and we'll all be happy, and we're not going to leave it to the last minute, right? Deal? With me on this? Okay. I remember I could hear you all saying yes. Okay, let's keep going. So if I click on that report, it'll bring up a PDF with the questions in it, and I'll maybe we can talk about these in a little more detail. One of the where you find this, of course, this PDF here is on our class website under this schedule page. There's a whole little block for this week's class on project. Find a gene project assignment, and you'll see a description of it. It's a required assignment for this course. You may wish to consult the scoring rubric right at the end of that report. So let me pull it up here. I'm going to click here on this example report and then pull that up here. So let's see how that works. Yeah, great. So I've got it right here, so you can see question 1. It tells me here, tell me the name of a protein you're interested in. Okay, so I picked beta globin. You can pick any other one in the universe that isn't beta globin, and I include the species that I'm most interested in, and I'm kind of biased. I like humans, right? So I'm picking humans here, and I tell it the accession number. This is the RefSeq accession number for the globin that I pick. That's a good idea to pick a RefSeq accession here as well when you're doing your own project. And then I go searching, I go looking, I do a little bit of a detective hunt, similar to the things we've been doing in our lab class, and I go and I search ESTs, express sequence tags, and I find something in nematodes, in worms, right? These are model organisms, of course. The C. elegans you might have, of course, heard of, but there are others. This is the nematodes like Briggsii and others. And I find this beta globin-like thing in there, and I go and dig into it and say, has anyone realized that this is a beta globin? And am I sure it's a beta globin? So these questions will guide you through it. I'm going to put in a screenshot of what I'm doing. I search for this thing here in nematodes, and I chose this particular hit. I show my BLAST results. Critically, I show the table of score statistics, like it's got a good coverage, a good low e-value, meaning it's unlikely to be a false positive, and it's got a pretty good identity score, 47%. So it's not exactly the same thing. It's definitely different, but it's still likely to be a homolog, and that's the key here. This kind of sweet spot that we want to appreciate. What is homologous? What is descended from a common ancestor? And close enough that it likely still is a globin-like thing and doing globin-like functions, or in your case, functions related to the gene that you're interested in. And then we go and annotate it. No one else in the world knows that this is a globin, but we do. We can follow this trail and go and answer these questions further on in this report and prove it. We can do alignments here of this thing. Here's the protein sequence from this nucleotide sequence that I've translated. And I go and I prove that no one else has seen that this is a globin before. I go and search in the main databases here in NR. Remember this, the non-redundant protein sequence database, the NR, the large one, and I search for it and I find a hit back. It's not 100% identity. If it was 100% identity, 100% coverage, that means that my sequence was in there. And if it's called globin, then someone else has already realized that this is a globin in this species. In this case, I don't find a hit with 100% identity, 100% coverage that's annotated as a globin or a hemoglobin. So I've found a new globin in these worms. And I want you to do the same for your protein or gene of choice. It'll probably be a protein coding gene, because then we'll have more to work with later on. So that's the brunt of those first 4 questions. And you can see I'm putting little screenshots in. I did this in Microsoft Word, right, and put them in, and then saved my report as a PDF, and I submitted it to Gradescope, and I got full marks, just like you'll get, right? You'll get your thumbs up, and then we'll go and dig in later sections of the report. You'll see, and you can scroll through this at your leisure. We make more multiple sequence alignments, these trees or dendrograms, these phylogenetic maps that we'll talk about, and heat maps. These are all made in R, and we delve into the structure and other things, and look at drug-like molecules for this protein that we might begin if we were going to take this further and start working on this in the lab, and we wanted to test its activity and prove maybe that it is a globin. We would take one of these compounds that we find that works on other globins and see, for example, here if it has an effect on these worms. That would be a reasonable first starting point. So please, I realize there's a lot of information to digest here. There's 10 questions. Have a look through them, concentrate on those first 4 questions initially, and get us something back as soon as possible. Submit it to Gradescope, and you see that we grade things pretty quick. We'll give you a thumbs up, or maybe think again, this isn't going to be a good candidate later on. It maybe will not give you the right amount of material so you can get full points later. So we'll have that check-in point, and then off you go, okay, to get full marks. Okay, so good luck everyone, and of course questions on this are very welcome whenever you have them. On Piazza is a great place to post them, or in office hours. Okay, so with that, I'm going to go back here to our slides, and just to recall that here that, yeah, there we go, we're back. So as I've already stressed, I think I've stressed it enough, 2 submissions. Question 1 to 4, May 5th, full thing, June 5th. Okay. So with that, I'll pause for a second and allow you to pull up our week 4 section of our class website. You can just scroll down on our class website. It's just right below the project description here. And now the hands-on section for this week, you don't have to submit anything to Gradescope, but I do want you to read it. It's a description of some important information about this programming environment called R that is very difficult for me to get to you in current Corona light course kind of format without just letting you read it. So I want to encourage you just to read it and take the code that's in there and type it out into R. Don't just copy and paste it, type it out, because that really does help cement the kind of structure and the syntax that we're doing. You'll see it repeats, the same stuff repeats over and over again as we do more advanced and more interesting things in the weeks to come. And the more practice you get, the better you'll get at this, the easier it'll become. That's why we have Data Camp and these other resources to help you learn these things. It's all about repetitive, deliberate practice. That's how we learn any language, and computing languages are even worse than real languages, because there's no room for ambiguity. You can't just mispronounce something and people will guess that you mean this thing. The computer is infinitely patient with you, but it's also infinitely dumb and inflexible with you. If you type something just slightly wrong, even though it looks correct, the computer's like, I have no idea what you mean, boss. I love you, but you typed it wrong, so I'm out of here. I'm giving an error message. And that's frustrating, right? It's not like going into a shop and you've learned French and you can point at the baguette and mispronounce it and they'll guess what you mean. The computer will not guess, okay? So let's have a little recall. What we're talking about is R. This is the language we're learning here. This is the logo for R itself, okay? So R is a separate thing from RStudio, as we discussed in our video lectures. And just briefly, this slide we used in our video lectures or pre-recorded lectures too. It's a language and an environment for statistical computing and basically for data analysis. And it provides this unparalleled environment for data analysis. In fact, you can't get this functionality in many other places. Now, the big problem, or the frustration, but also, as we see later once we learn it, the great power that comes with this approach, is that it's script based. It's not point and click. It's not Excel. It's not, you know, GraphPad or Prism or some other kind of statistical software where you point and you click and you choose from menus. You have to write. You have to code. It's not graphical user interface based. That's GUI based thing. So you will have installed this already. I've stressed this quite a few times already, and I don't want to stress it further. But if you're on a Mac and you open it up and it looks like this, you haven't opened the right thing. This is R itself, which you get from CRAN, right? This is the R GUI for Mac, and that's the wrong thing. We don't want this. That's not that icon that I've just put the little red box on up above here. It's the one below, this icon, R Studio. This is a separate thing. This is an interface to R that'll help us learn it in a more friendly kind of environment, this R Studio. If you're on a PC, if you're on a Windows computer and you open up what you think is R Studio and it looks like this, again, you've done the wrong thing. This is the R GUI and it's not the right thing. This is a pretty unfriendly and actually rather ugly looking window, right? So close that down if you have it. What you want is this thing, R Studio. So make sure we've opened the right thing and then we can start playing with this, right? Now, well, there's a couple, but this is one of the most important ones. Setting changes that we can make that will make our life less painful later on is this. We're going to go to the tools option right along the top box and make sure that this restore our data into workspace at startup is unclicked. And we have this little box that I've highlighted in red here set to never on exit. What this would normally be clicked on by default because it's the settings R itself comes with. What the R history is, or the R data in the history is it'll save all the things that you do in a given session, and then next time you open R Studio up or R itself up, it'll have those things available for you. And that sounds, you know, on the face of it like a good idea, but it's dangerous. And what we've seen in our class in the past, you know, in the previous couple of quarters that we've been teaching this, is that it leads to a lot of confusion because maybe we make some work one day and we make our results and we save it as my results or my genes, my top genes or something like that. And then you quit that project, and that was an RNA-seq project. And then we go and we do some proteomics project or do something else the next day. And we open up R and we type something and it didn't work, but you wanted to save the results as my genes. And you pull up this thing, oh, my genes, this must be my proteomics result. It's not. It's the ones you saved that you were working on the last time, right? And then it confuses you. Why do my results look weird and different? Why are all these asthma-related genes coming up when I'm interested in HIV infection this week, right? So let's save ourselves the heartache and the pain, and it'll actually allow us to be more reproducible later because we want everything to be self-contained within a given project or a given week. We're going to click these things off. So please do that now. It'll save us heartache later. So how we do this is we would go to R Studio. I'm going to pull my R Studio up and make sure I have that setting too. So I follow my own advice. So here's R Studio. I'm going to open here the tools menu, which is off the window. I apologize, but it's up the top, third from the end. And I'm going to do global options right down here. If you can see tools, global options. And I open this up, and general, I'm going to click this off. See this restore our data into workspace, this thing right here. Make sure that's clicked off. And then this one should be on never. So make sure that says never. So these are the two options that we're going to change. I'm going to say OK and store that. And now I've got the default looking R Studio window right here. And it's fine, you know, it's very white and kind of, you know, I'm getting kind of sunburnt in my back here from this thing. It's so bright. So I'm going to try and be a little kinder to our eyes, and I'm going to also change the color profile here. This is optional. It doesn't affect the way the thing works. It's just my preferences are for a darker background and lighter text to avoid eye strain when we're working on computers for doing this kind of detailed kind of work. So I'm going to go back to Tools, Global Options here, and I'm going to click on Appearance. You see it's third down in this list, Appearance. And by default, this RStudio theme is set to classic. I'm going to change it to modern because, you know, I fool myself and think I'm modern. So I'm going to click modern. The zoom settings, I've got about 125. That's probably okay. I've made, you know, for you at the start, it's probably 100%. I've made my font and everything, font size is bigger. I've zoomed in here just to help with my old eyes looking at this screen. And then I'm also going to change this editor theme to a darker one. I'm going to click Cobalt in this case. See this one here? I like this one. It's kind of bright and vivid and will stand out better in these videos, hopefully, and when you're on your screens too, if you choose. Again, this is, you're welcome to go pick Dracula if you want, or something else, right? Go explore, and some of these are quite different, right? Light themes and others. I'm picking this one because it's one of my favorites, and I'm going to say you can click either apply and then OK, or just OK directly, and it'll restart RStudio itself. And now I've got this darker theme, which I think is more easy on my eyes, at least, and hopefully for yours as well. Okay, so those are just two little settings that we've changed. Have a play with them and see if you can arrive at something that's visually appealing for you. Again, we're going to be working in this environment for quite a while, so pick something that makes you happy. You know, it's all about these little wins, right? And then let's concentrate on this RStudio console window. This is the first window here where the little cursor is blinking at us at the minute. And right here, if you can see me clicking right here, this is the R brain that we keep talking about. This is where our commands will eventually end up, regardless of where we type them, and then be executed by R. Okay. So let me start here, and we'll go back to the slide deck for a minute so I can keep myself on track. And we'll go here. So this is what we did. We did this, and then we also changed our appearance. Those were the settings I picked. I picked a slightly larger font size, a zoom setting, and a different editor face or theme to make the dark appearance. And then these are the two windows that we're going to focus on: the input window, the console, the R brain, so to speak, where we enter code, and also this output panel, okay, where plots and graphics and our results will appear eventually. Now, on our class website, if I pop over here for a second, on our class website, you know, we're on week 4. The hands-on lab, it's not very interactive, and there's nothing for you to return. And I did this on purpose because I realized we're at that point in the course where, you know, I've asked you to submit quite a lot already, and I don't want to overburden you or de-enfranchise you from it. So this one is just read it and take it in, take notes, and take these things and type them in to that R brain and see how they work. Okay, this is all important information. Some of it may seem a little obscure at the minute, but it'll come back to be useful as we go through. So let me then leave that with you if you haven't already done it. And what we'll do here is we're going to briefly summarize the most important. They're all important points, but I'm just going to summarize the handful of most important points from this hands-on worksheet, and we're going to focus in first on these things called vectors. Something that comes in R and makes our life a lot easier is a thing called vectorization, and also data frames. So I'll pause for a second while I pull up RStudio and start typing these things. And I'll also check in our, I'll go over here for a second, and I'll check in our Piazza form to see how we're doing. Okay. No questions. Nobody's alive. I'm talking to myself. Okay. Coffee helps. All right. What we're going to play with, whether you've got the dark theme or the like theme, it'll all be pretty similar. What I'm going to do here is start and make a vector type X. So this is a, let me zoom in a little bit further maybe. Make this window slightly, this panel slightly larger so you can see it. I'll click this little broom icon to disappear all the droppings. So you can see my cursors up here. I've typed X. Let me do it again, X. And then I'm going to do this assignment operator. You can use the equal sign if you really want. I encourage you not to. And indeed, in the hands-on section that I pointed you to, I go off on a bit of a rant about why we use this operator, and we'll see that we can use the arrow in both directions later. Years ago, and I'll show my age a little bit, back when I was first using IRX, Linux, Unix computers, we actually had a key that was an arrow, right? There was a button on the keyboard that was an arrow operator, and that was the one that we used for this stuff for S and then R as it became. So I'm going to use that, and we'll see that we use the equal sign mostly when we use functions and assign arguments to functions. So I'm going to type X 1 to 5, and I push return. And what happened? Well, not much, right? It kind of changed color, and nothing was printed back at me. That's because the 1 to 5 I have put into the X. Where is X now? Well, it's in our environment. It's in the R brain. R knows about it, and I can recall it. So if I type X and push return, it'll print out whatever is in that object that I created. I picked the name X because I'm lazy. It's something we use quite a lot. And you'll see over here, if you can see where my mouse is. I don't know if this thing will work. Let's check. So over here, no, maybe it doesn't work. I apologize. So here in this environment panel, if you can see where my mouse is right here, there's a thing called X. That's the objects that are available to R to do stuff with. And it printed out this thing with square parentheses here, this 1, and it's got some numbers, right? So I can, what is this 1? Well, I talked about this in the video. If we made X larger, let's do X 1 to 50, for example. Okay, so this will make the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 50. And then I print X. See, it prints out that 1 again at the start of the line. And here my window width is 17 characters long. You can see the 17 is at the end. So it's telling me that, hey boss, look, the first thing I'm going to print out in the second line here is the 18th little bucket or element, to be more exact, of this vector. It's the 18th little bucket, and this is the data that's in it. And then it prints out another 17 of these things, and it says, hey, you know, up to 34, and then the next one it says, hey boss, look, this first element is number 35. So it's just a little signpost for us to know where in the vector we are when we print these things out. That's what the little square parentheses do. We can use those things to access. For example, if we wanted the 18th position in this vector, the element of this vector, if this had some data that we were particularly interested in, we can use square parentheses, that number, and go get it, okay? So that's fine. We can do, let's make X smaller again, just so it's easier for our minds to deal with. So this thing here is 1 to 5 in length. R is vectorized, so that means I can do things like X plus 100. And I push return, and it prints out 100, you know, 1 plus 100, 2 plus 100, 3 plus 100. Those things that are in X, all of them in turn, each element of the vector is operated on by what I just typed. I don't have to loop explicitly or do some for loop like I might have to do in other programming languages, for example, and iterate through every element of my variable here. R just does it for you and happily carries on. And that makes life a lot easier, right? We can do all sorts of apply functions across the whole vector, like if we did the log of X, right? It'll take the natural log, as we see here, it'll take the natural log of every element in that vector, right? So we can apply functions across the whole vector. We can do any sort of math. X times 100. So times here is the little star character, or and division is the little backslash here, and it'll do this all for us in a vectorized fashion. So that's very helpful. And so let me tidy up our droppings for a minute here. You know, the screen here, the R console will just keep going and going like a page that keeps running down and down, and we'll get to the bottom of the page here. I'm going to tidy it up with the little broom icon, and I'm going to ask you a question. So we did x, which was, you know, 1 to 5, and we did x plus 100, and we saw that it was 101, 102, 103, 104, 105. What about this? What about x plus, and let's do something like 100, 1, maybe 3 ones, and then 100. What's this going to give? What output do you think this would give? So remember, in X, as we see over in the environment panel up top right up here, it says it's a vector, it's of integers, it's from 1 to 5, and I added 100 and I added it to every element. So what's this going to give? Well, the second vector here that I'm adding on, it's got 5 elements in it, so it's going to add 100 to the first value of x, 1 to the second value of x, 1 to the third value of x, 1 to the fourth value of x, and then 100 to the fifth element. So if I do that, I should see 101, and then 2 plus 1 is 3, and 3 plus 1 is 4, right? Advanced math required for this course, right? And 100 plus 5 is 105. Okay, so it'll work element-wise if you give it a vector of the same length. Okay, what about this? Okay, what about x plus, so let me zoom in a little bit more actually. I apologize if that's too small, so I'm going to make this font even bigger here for us. So what about x plus, and I'm going to do 101. So here I'm taking my x, and what I'm doing here is going to add this 2-element vector onto it. What is the output going to be? Can you think for a minute? I'm going to pause here and let your little brain, not little, your big brain, think about what will the output here look like, right? What do you think? Shout it out. I can't hear you. Shout. Ah, okay. So an error message, someone said, right? It could give an error message because, you know, what's it going to do here, right? Well, did anyone predict this? It gives some red text. Red text, scary. It should not scary. It's a warning message. We'll talk about that in a moment. But let's look at the output. It still does it. R still goes, I love you, boss. I'll do it. I'll help. I'll help. And what it's given me is 101. Okay, so that's like 1 plus 100. And then the second element is 3. What's that? Well, it's taken here the, you know, remember that it's taken, so this was my input vector x was 1, 2, 3, 4, 5. So it's taken 1 plus 100 to get 101, and then it's taken 2 plus 1, oh, I'm not accurate enough, plus 1 to give my answer 3, and then it's gone back to the start and taken one of the second vector and taken 100 plus 3 to give 103, and then it's gone and taken the second element, 1 plus 4 to give 5, and then it's gone back and taken this one, 100 plus 5 to give 105, right? I meant to only highlight this, I apologize. So what's it doing? Well, it's recycling this shorter vector, right? This shorter second vector to say, oh, well, I can't do it exactly like I did up here because it's not the same length as x. It's not 5 elements long. So it recycles it. And in fact, when we did x plus 100, it did the same thing. It just, this was only 1 element long, so it just made it 5 100s, right? So it was 100 plus 1, 100 plus 2, 100 plus 3, 100 plus 4, 100 plus 5. So it made this 100 the same length as x. And here what it's doing is the same thing. It recycles this 2 elements in sequence, so it'll become 100, 1, 100, 1, 100, 1, right, until it's length 5, and then does that element-wise addition to give this answer. And it tells me, look, hey, buddy, is this really what you wanted? It says this C101 longer object length is not a multiple of shorter object length, so it won't fit exactly. I did that on purpose, 5 and 2. So it gives you a warning message. It says maybe you want to pay attention, maybe you don't. Life's too short, carry on, or pay attention. And you've maybe made a mistake that you didn't realize you made a mistake. Okay, so a warning message is not an error message. It is just what it says, a warning. It's not fatal warning. It's just, whoa, think about it. And if you're happy enough, okay, carry on, or not, right? Go back and think about it. It doesn't give you an error, it doesn't bum out or crash or anything like that. It's just a warning, okay? So don't be intimidated by this red text that'll appear. You'll see red text a lot as we go through learning R, but try and read it. It might sound like gobbledygook initially, but as we go through, we're going to learn more how to speak this geek language and interpret what these things mean. In this case, it's telling us longer object length is not a multiple of shorter object length. So X is an object, this C101 is an object. These are these things, and they're not the same length, and they're not a multiple of each other, so I can't fit it exactly when I recycle it, so I'm going to give a warning. So that's the idea there. Now, one last thing that we talk about in, well, it's not one last thing, but one more important thing that we talk about in that hands-on sheet is that these vectors can have names. The elements of a vector can have names. So let's make one up. Let's go and say, let's make a new one like y. Here we'll call it, and we'll do, so C is the function that it's for concatenate, right, to concatenate these things together. Concatenate means stick things together. So I'm going to do, let's say they're, like we did in the video, maybe scores for homeworks, like homeworks in this class. Let's say we have a student, Alice, okay, and she scored, well, yeah, let's just do a character vector first. Alice, and Jim is another student, and maybe Chandra is a student, and then let's do Eliza is a student. Okay, so this is a character vector now, right? So this is Y. I can print it out and it'll spit it back at me. Notice everything is printed back with these quotes. It's 4 elements long, 4 students that we're talking about here. So I can't do the things that I could do with X, like add 100 onto it, because it's characters. What does 100 Chandras look like? Well, that might be scary depending upon who Chandra is. So let's do Y plus 100. That tells me error. We've got an error message, right? Error message here. This error message is telling me that it says non-numeric argument, which means it ain't a number. I can't do math on this thing, boss. I can use other functions that work with character vectors. Like I could do something like, let's say Y, let's do paste. Paste is like where we're going to put things together, paste, like wallpaper paste, or not necessarily your copy and paste, but paste things together. So I'm going to say Y, so that vector, and I'm going to give it a second string here. Let's say loves R. Okay, so Y, comma, loves R. These are 2 arguments to this function called paste. We can look at the help page and see what paste does in a second. I'm just going to run it here, and what it'll print out is a vectorized answer. Alice loves R, Jim loves R, Chandra loves R, Eliza loves R, right? So that's a vectorized version of working with this character vector. I can't do math on it because it's character, of course, but I can do character things. How about if I used X as input? I'm going to notice it looks like I typed that really quickly. What did I do? I pushed my up arrow key, the arrow that I use, to go left and right and up and down on my keyboard. I push the up arrow key, and it recalls my previous commands. It recycles through all the commands I've done in my so-called my history. Right, see that? So I'm going through all the commands. I can go the down arrow to go back in time. forward in time, up in time. So I'm going to recall this last command and just edit it, and I'm going to change y to x here. And remember, x was this vector of 1, 2, 3, 4, 5. What do you think this is going to do? So think before we do it, because we're going to check our understanding, check our mental logic, explicitly make it, invest in this and think something and say it out loud or whatever it is. There's a classic rubber duck debugging thing, right, where people say, I can't solve this problem. I don't know how to solve it. I can't debug this code, but we get a little toy duck and you set it on top of your computer or somewhere and you explain it to the duck, and then magically you fix it because you've actually had to vocalize and actually explain it to something, even if it's an inanimate object. It can help your thought process and your brain work. So I'm going to say, what is this? Paste x loves r, and because I can't see you, I'm going to pretend I have my rubber duck here and say, hey, rubber duck, I think it's going to give an error message, or because it's a numeric thing, or I think it's maybe going to work. Maybe it's going to say 1 loves r, 2 loves r, 3 loves r, 4 loves r, right? And indeed it does. It's the second case. See here, it's the first element returned is 1 loves r, 2 loves r, and then the fifth element, because it recycles. Remember this recycling? It'll take the second argument, this loves r, and recycle it as many times as it needs to be the same length as the longer input, just the same as our plus did and our math did, this recycling. Okay, so that's an important aspect of using r. It can help us a lot. It can also maybe cause problems if you weren't expecting it. Okay, really useful for interactive work, but something we're going to guard against later when we write these things in scripts and automate our work and things like that. We're going to check for this recycling if it happens when we don't mean it to happen. Okay, so we'll come to that later. Okay, so another type of, so we've got some characters. One last type that we'll concentrate on. I'll do my broom and clean up here. One last type is logicals. So we can have, I'm just going to shorten it to TF TT here, and let's call this Z. So I'm going to go, not TT, I mean T. So you see how the commas, just like the numbers, I had one and Alice and all the rest of it were comma separated. Just like all functions, the arguments are comma separated. So Z here, or Z if you want to be correct, is TFTT, which stands for true, false, true, true. This is another type, not character, not numeric, but logical. We'll see that these logical vectors are really useful later for us because we can use them to look at conditions. We'll see. We'll do an example maybe in a moment of this. But here, what if we do remember our math? What if we did Z plus 100? What's this going to give? Well, it's not a character vector, it's not a numeric vector, but it actually still works. How does it work? Well, let's look at the answers. You see it says 101, 100, 101, 101. That's because trues can be, the true-false vectors, or the logical vectors will be considered as ones and zeros, where ones is trues and zeros are falses, if you're going to, if it needs to do that. Right? So R will what's called coerce things into the most permissive type, or the most useful type. So if we took, remember we had a vector of Alice and Jim or something like that, right? Or let's do Chandra with capitals in this case, and we put some numbers like 10 and 22.5. What's this going to give? I've got numbers and names. It's going to print it out all as characters. You see the 10 here is in quotes and the 22.5 is in quotes. R has under the hood said, okay boss, you obviously have characters in here. Let's make them all characters so you don't screw up. Okay, but it does mean I couldn't now do math with this. Even though there's numbers in here, I can't add 100 to these, for example. It's going to say no, non-numeric argument. Everything is a character. Okay. Okay, what about if we did our paste? Remember we had our paste. I'm going to recall it back from my history. here where we had remember we had Y, which was all the names of the students, and it said Alice and Lisa and everybody loves R, right? What if we did Z loves R? What would that give? Well, it says true loves R. It's still this true false thing. It's not ones and zeros, it's true falses. Okay? But it's a character string. Okay, so let's go maybe and do the final thing that I want to mention or highlight about vectors is that these things can have names, and that names are really useful. You'll see that they're extremely useful for data frames in a moment, but they're also very, very useful for vectors. So let me clean up my drop-ins. And I had Y here, and that was these students. Let's see how much they actually like R. Let's give some test scores. So I could do grades here, and I could either do it. I could do it two ways. I could just give some numbers like 10. Maybe Jim got 6, and Chandra got 7, and Elisa got 9, for example. Right. So I'm writing this the wrong way. I'm going to do grades equals this. So these are a numeric vector: 10, 6, 7, 9. If I print grades here, I can say names of grades. So I can assign names to it like this, equals Y. Okay, so if I type grades now, it has these names that come along with it, like labels for each element of the vector. I could have done, let me do this another way, which might make it more clear what I'm doing, perhaps. I can say, let's make grades again, so we'll override it here. I'm going to say C, and what order was it? I can't remember. It was Alice, I think. Alice equals, let's say Alice got 10, as we said. Jim, he got 6, and then Chandra, let's pretend that Chandra fictionally struggled in this one, got a 7, and Elisa, so I'm putting them in quotes. These names did pretty good, actually. Okay, so here it's just the wrap of the pages has gone there, so I'll make it bigger. So if I print out grades, it'll look equivalent to the last time. It's still a numeric vector. I can still do math with it, right? So grades. So if I did, grades divided by 10, right? That would give you the proportion, and I could do times 100 to get the percent they got in every test. Alice got 100, Jim got 60, Chandra got 30, right? That idea I could have also just multiplied it by 10 here, of course, right? It's the equivalent calculation to get their percent scores. So I can do math with it, but notice the labels all come along with it. So that means I can do cool things, right? I don't have to remember that Jim was the second student in the class, or that he was the second one to submit work in this case, right? I can just ask, what grade did Jim get? What did grades, here RStudio's trying to help me see this. It's trying to say, oh boss, do you mean grades? And I can just push tab to autocomplete that. And I can say, grades, tell me what Jim got, please, in this. And it tells me Jim got 6, right? The original score up there, not the percent score, because I haven't saved that. I can also sort the grades, and it'll give me them here with the lowest first up to the top. If I wanted to change that, I can argue with this function to change the sort order. Here, for example, let's pull up a help page for grades. So how I pull up the help page is with the question, not for grades, for sort, the function that I'm using. And if I don't type anything, so you are trying to say, hey, do you mean this one or some of these other ones, right? I do mean this one. Sort a vector into ascending or descending order. I can push return here and pull that up, and I've made my windows very small, but I'm going to click this little pop-up window beside the home-like button, right? And that'll bring up a bigger window here. Let me bring it forward here. And this tells me that, as we talked about in our video, the function sort, x is going to be our input, and it says decreasing equals false is the default. If we look here, it says logical. Should the sort be decreasing or not? So I can flip this from false to true, and let's see what happens. So this is how I'm reading this help page. So if I recall my command, and I could do decreasing, I'm going to use RStudio to help me. I push tab here, and it says, do you mean this argument? And I say true, and it returns them in the opposite order, with the highest first, rather than in decreasing order. It'll be in ascending order. Okay, so I'm arguing with this function to change its behavior by adding this decreasing equals true argument. I could also do, who got the lowest, which, just using different, which dot min, for example, who got this lowest grades, who got the lowest grade. In this case it was Jim. He was the second element, or that was the second element in the vector, for example. I could say grades, and let's look for students that we might want to follow up on. Let's look for grades less than 8, for example. Right, so here this little arrow is means less than. So this will return a logical vector. It's saying, no, Alice was not less than 8. Remember, she got 10. Jim was less than 8, if we remember. If we see our grades, Jim only got 6 up here, right? And Chandra got 7. So they should both be less than the 8. So it's false, true, true, false. So Jim and Chandra are the two students that we might want to follow up with here and see what the misconceptions might be or what questions they missed. I'm going to use that to see what scores they actually got. So I'm going to take that true-false vector and use it to look up grades. What this will return is, it won't return the first element of the vector, it will return the second element and the third element, which is Jim and Chandra, and it won't return the Alisa, the fourth element, so it returns those two. So I can use this logical to access vectors. I can use the name, like grades in quotes, Chandra, to look up Chandra's score, or Jim's score, or whoever's score. I can use the names to access these things. And I can also use numbers, like what did the second student get, grades, square parenthesis 2 would give me the score for the second student, or I can use these true-false things. This will be useful, these logicals that we're using here when we construct this thing, like is 10 less than 4 or less than 5, and the answer is false. It's not. Is 10 more than 5? The answer is true. Yes, it is more than 5, right? So these return logical vectors, in this case length 1, but in our case when we were doing our grades, they'll be the same length as the grades vector itself. Okay, so let me pause there and wait for questions, because that's a lot that we covered. We covered vectors of different types, those logicals, these true-false things that we just covered. There were character vectors and there are numeric vectors, and that they can have names and we can use those names to access them, as well as numbers within these parentheses, these square brackets to do data access, what we call subsetting of vectors, getting to the little elements within a vector that we want. Okay, so let me return here to our slide. So these are vectors that we talked about. So vectors are one of the major data structures within R, along with data frames, the other major one that we'll focus on in a second, and lists that we'll see a lot, as well as matrices and arrays. So these things, these elements, these vectors are one-dimensional containers for data. They all have to be the same type. Remember that if you put numbers in with names like Chandra and things like that, it made them all characters. Or if you put characters in with numbers, they'll always go to characters, right? Now data frames are different. They're for tabular data, and they can be stored data of different types within their columns. So we'll pull up and make some examples of data frames in a second. Let me just pause for a second and see if we have any questions. Hopefully there shouldn't be too many burning questions. If there are, you can ask them, of course, in follow-ups and in the office hours, as well as now in the live session on Piazza. Hopefully the data camp course has been helpful in walking us through a lot of this stuff and made this more of a review session as it's meant to be. There's a question from Laura. Thanks for the question, Laura. So I'm still a little confused about the project. We're supposed to find a gene that nobody knows about, or are we just looking at genes that have less than 100% identity on NCBI? It's based on the annotation, Laura. So it's find a gene project. It'll be a gene that you're interested in. So it will be a gene that people know about, that's something that you've covered in another class, or that you've read about, or that you've been exposed to in a research environment if you're volunteering in a lab, or something you've just found from your own interest. But then you're going to go and find an example of that gene in some other organism that nobody knows it's that gene, right? That's the novel aspect. It's novel in that no one, in my case, everyone knows, well, not everyone, but lots of people know about beta globin, but no one knew that in that particular worm species it had that globin, right? No one had annotated that before on the planet. I was the first to know that, to find that, and we use these bioinformatics methods to find it. That's what's novel. Okay, so have a read through those questions, and the 100% identity on NCBI is a bit of is not worded carefully enough in your question. What we mean is, if it's annotated in the NR database, that database that is maintained out of NCBI, the NR, the non-redundant database, as that particular sequence, right? So that would be 100% identical, 100% coverage. That sequence from that worm that I was looking at, and it had a tag on it saying this is a beta globin, then it would not have been novel. Other people would have known that this beta globin exists in this worm, right? It's in the databases and it's annotated. In my case, it wasn't. In your case, your gene, whatever it is that you pick, should be novel as well, right? It shouldn't just be sitting there in the database already annotated and the whole world knows about it. Does that make sense? So that'll be question 4 when you go and search what you find back against the NR database. Okay, that's going to be the most challenging question of the first 4 is the 4th one. Right? Okay, I don't see any more questions coming in, so I'm going to go back. Oh, thanks, Laura. Appreciate it. I'm going to go back to my RStudio here, and I'm going to clean up my drop-ins. You don't have to do this. This little broom icon is just so I can you're not looking down the bottom of the screen where it's harder to see in the YouTube window, but towards the top. It's completely optional. So let's have a little play with data frames for a minute. I'm going to make one, and I'll be uninventive and just call it DF for data frame, right? And I'm going to put my little arrow assignment operator in, and I'm going to make a data frame. And how I make data frames, usually, most often, as we'll see, is you just read data from files, tabular files or CSV files or Excel files or from a database or somewhere else. And that data will often be organized as tables, genes down one column and some values about the genes like expression or their spectral counts or whatever, right? Down different columns or repeat experiments. And it's naturally kind of tabular. So data frames are the way we store kind of tabular data now. It's not like the vectors, which were these one-dimensional little containers. These data frames are two-dimensional, so they'll have rows and columns. You can make them by hand, as I'll do now, with the data.frame function. But generally, it's not used that much because we normally get our data from other sources, but I'm just going to make one up. So let's show that we can put numbers in these things. So I'm going to do, I'll put column names on these. So nums here stands for numbers, and I'm going to put 1 to 5 in it. So that'll be the numbers 1 to 5. And then let's do one with characters. So cars here stands, I'm just lazy and I'm not typing out the whole word. You'll see this is a common theme in bioinformatics and programming generally. If we can abbreviate something, we will, because we don't want to type too much, right? And that's great because it saves me typing, but it's pants because newcomers go, what the hell does that mean, right? They don't know what abbreviations you're using, and this is particularly true whenever we look up functions and the help of functions, you know, and it says some obscure little argument that we don't know unless we're speaking nerd speak. But we'll get there. We'll get into this mode. So I'm going to pick some characters from this inbuilt vector that comes with R, which is the alphabetic, the alphabet. It's all the characters of the alphabet. I'm going to pick it's a vector, so I'm going to access the first element of that letters vector, so that'll be A, then the second B, C, D, right? So I'm accessing just those 5 first letters of the alphabet. And then let's put in maybe a logical, and I'll put in, we'll make it 5 as well, so we'll do our true. And you could write out the full thing. You can write out true if you wish. You can also just do T and F. Again, you see this kind of, let's call it efficiency, not laziness, right? This efficiency of keystrokes. T is an abbreviation of true. F is the capital abbreviation of false. It's probably a good idea to write out the whole things, but so let's do a true, true, false, true, false. Okay, so that should be 5 in length as well. So I push return. I'll see that DF appears up. If you can see where my mouse is, I know it's a little small here, but my cursor, my mouse cursor is here in the global environment. P in your window probably isn't squished in like mine is here, but I'm just going to click on this thing, DF here, and it opens up this little view of my table, like an Excel-like kind of spreadsheet or spreadsheet-like display. So I've got my numbers 1 to 5 here. I've got my characters A, B, C, D, E here in logical. Where does those letters come from? So if I just type that, you'll see that it's just the letters of the alphabet. So what I did is if you wanted the 6th to the 10th letters of the alphabet, it would print you out. What I asked for was the 1 to the 5th. Give the first 5. Right. So it's just a little convenience inbuilt function with our alphabetical letters here. So that brings up this little table. I don't need it here. I'm just going to close it. But I just want to show you that it's arranged in columns. If we go back to where we made this thing, we said, give me a first column, please, of numbers, or called nums, which is 1 to 5. That's what it's done up here, 1 to 5. And then a second thing of characters, and then logical. Okay. So let me make this thing bigger again. I can, DF was the name of it. I could print it out here as well. Okay. And I could do DF, and I can use square brackets for this too. And I would use rows. So if I wanted the first row, across the first row, so that would print out the 1A and true here. Or I could do columns. So for example, if I leave the other one blank, it'll print out those characters, or those numbers, or those characters, or the third one was the logicals, or the logicals, right? So there's our little table. And I can use the square parentheses to get to any element of it. So DF, if I wanted to get to the 4th row, so let me see, I want to know this element, right? How would I do it? Well, I want to access its rows first. So I do 4, that would give me the whole 4th row, and I could do the second column. So 4th row, second column will print out D. Okay. Now the other way, and you'll see this a lot, to access these things is by their column name. So df, and if I just type dollar, our studio here tells me what my column names were. Remember, those were the three things that we created. So if I want my logicals, I could just go and say, give me the logicals, and it'll go get them for me. Okay, or df dollar nums, and it'll do that one. So there's this dollar syntax to access the columns, or we can always use the square brackets to access rows and columns, or some subset of them. Okay. So that's data frames for this tabular data. All my functions, that vectorized nature of things, because underneath the surface, all this is a collection of vectors arranged in these columns. So I could do, the same stuff. I could do sum of the df dollar nums, right? I can take sum of the numeric columns, or even the logical columns. Remember, that can be converted. When I do this, it'll be converted to ones and zeros. 1 for true, 0 for false. So in our case, it's going to be 1, 2, and it's not going to count this one, 3. So the sum is going to be 3 in this case. So let's make sure. So that's the sum is 3. That's our ones and zeros added up. So we can do math with those things. Of course, I can't do math with the character column, right? The cars column. It's going to give me an error message, say non-numeric thing. Piss off, right? That's what it's basically saying here. Go think again, boss. I could do, and I've seen that I can access that second column here, the one that has the excuse me, sorry, butterfingers. I can access that one here. I could also use, let me bring this up to the top. I can also use a minus subscript in here. That'll give me everything but that second column. See that? Remember, df itself had the 3 things. Now what I asked up here was, give me everything but column 2, please. So it's like taking away that second column. That's with the minus subscript. If I wanted to take away the first one, you got it, -1, right? If I wanted to take away the first column and the third row, I would do it here. So you see now it says, the output says 1, 2, 1, 2, and then skip 4, 5. That's because I've taken away this third row, and I've taken also away the first column in this case. We'll use this to quite often, to get the genes we want, the most important things within subsets when we read big data sets in this indexing. So it is an important thing, but we're going to hit on it multiple times. If it's still a little confusing at this stage, don't worry, it's natural that this is a little different, but the square parenthesis and the fact that we have rows and columns for data frames is the important point here. So let's, oh yes, so show that things were vectorized. We kind of seen that. So the df, like if we had the df dollar, well, let's do the df -2, this one. So this, we can multiply that. I don't need the parentheses around it there. Maybe take them off. They don't hurt, but I could show that this is all vectorized. I can do that times 100, right? It'll just do it for me. I don't have to iterate through the rows and the columns and do a for loop like I would have to do in Python or something like that, or C, and do that. It's all vectorized and will work across the whole data set, which is cool because I read in my big, huge, 30,000 genes list and I want to normalize them. I can just call the function and it just does it all, right? I don't have to iterate through it. It's all done for me. Okay, so I think that's enough for these major data structures, vectors and data frames. The key points are vectors are one-dimensional and all the data in them has to be the same type. If it isn't, R coerces them to the most flexible. Normally that's characters, and that might not be what you want if you want to do math with these things. And the other thing is data frames, they're for tabular data where we have multiple rows, multiple columns, and the columns can be of different types, which is cool because it allows us to store annotations and gene names and other things that we're interested in along with numbers. Okay, so that's what we've done. Okay, let's move on to calling functions. What we'll do is let's just do plot maybe for this, like we did in our video. So we've been using, how you do stuff in R is use functions, right? Everything useful is done with a function. Everything's all the features and all the abilities to do stuff. Do a blast search. That's the blast function, as we'll see later, right? Or do differential expression. It's the D function that we use to do differential expression analysis. These sorts of things. How these things work, as we've seen to some extent, is we call the name of the function. So let's do it. Let's do plot. Well, let's remember our little vector of 1 to 5, x. See how I can recall it. If we don't have it, let's make it again x. Let's do 1 to 50, for example. So it's a bit larger. Now I'm going to do a plot of x, and I'll do it against the sine of x, just like we did in our video previously. So what this does is over here, it says couldn't find function pot because it's not a pot to p in. I wanted to actually type correctly, right? It's not a function. Pot is not a function. I want plot. And then it'll go off and do it. And my plot is teeny tiny and squished in, so I'm going to make it a little bigger. I'm going to zoom it here. And here's my boring plot. Okay, not what I want. So I'm going to argue with this thing. See, the axis labels are kind of responsive. You see some will come and go depending upon how much real estate. So this minus 0.5 here thing will disappear when I make the plot too thin, right? And this one disappeared because there's not enough room to draw them in this case. So that's fine. When we export them, we can export it as a bigger size. You can see there's an export button there over in this panel where we could save the image or copy it to the clipboard and paste it into Word or something like that, or PowerPoint or whatever you're using. Regardless, the plot is ugly. It's not something I want to paste anywhere. I want to argue with it and make it a little better. So I'm going to do plot. I'm going to recall it actually. I'm going to use my up arrow key to call it back, and I'm going to say, I don't want just a scatter plot. I want lines. So I'm going to do plot TYP equals, and then inside quotes L for lines. Give me a line plot, please. Now it looks like that sinusoidal thing that I was after. I don't like it still because it's dull and I don't like the color, so I'm going to do call equals, let's do blue. And that's gone blue. Let's maybe make it a little thicker so we can see it. LWD equals, let's do 4, make it really thick. So it's got a thicker blue line here. And if I zoomed in, I would see that my plot, if the window wasn't hidden somewhere else underneath, here it is looking a little better. It's still not the prettiest thing in the world. It's still pretty basic. We'll see in next week's class how to make really beautiful, compelling figures. We'll start using ggplot package and a bolt-on package for R that makes really compelling, pretty figures in a common format that we can use to make all sorts of different figures. What we're using here, this plot function, comes with R itself, right? That's why we're all able to use it, because we haven't installed any packages yet. So it's called a base R plot. It comes kind of with the base package. So we can argue with it and change every single little aspect of this plot, of course, and we saw that in the video. I encourage you to watch that video if you haven't done so, where we delve into those features about how to access the help page for these functions, how to learn what these different arguments are, There are many, many, many arguments to these functions. And the basic idea is, we call them arguments because we argue with them and we get them to do what we want, right? It's like, no, I want lines, not points. Or I want it blue and not black, or I want it red and whatever. So have a play with those things and have a look at that video and experiment. Type them out, see what happens. If you get error messages, that's a good thing. We learn, right? I learned here that I don't type very accurately when I'm looking in two different places, trying to look in two different places at the one time here. Everyone makes mistakes. Everyone gets error messages. I get error messages every day, right? And I've been doing this for a long time. I've written software used by lots and lots of people in these languages. So don't worry about it. Don't get frustrated by it. Just move on. How you respond to error messages and what you learn from them is actually really important. Right? That's the key to success in this field, is being a little stubborn and trying to move on past these things. So that's functions, and they all work kind of the same sort of way. If you function to do math, right, it was sum, and then you give it some input, right, like Rx, or not C, it was X, right, and it sums all the numbers up, or plot, and it makes a plot, or whatever. It's a name of a function, then regular parenthesis, normal brackets, the input to the function, and there can often be multiple inputs, and then we can argue with them, add more inputs that are optional inputs, arguments here, to get it to work the way we want. Okay, let's see. I think that given the time and my energy levels, let's go back to the slides and we'll finish off. I think we've done enough on this for today, together with our videos, that we can maybe call it quits pretty soon. So, one last thing to mention here is right at the bottom of our hands-on sheet that you're reading and working through. It talks about RStudio projects, and I probably should have put this first. The IAs are probably going, why didn't you tell them about this first? Well, what these things do is they allow us to be organized, right? We're going to create a new, what's called an RStudio project, right? It's basically a new session that takes care of all the bookkeeping for us for a given class. So each class from going forward from next week on, we're going to create a new project. Actually, let's go and create one now, and we'll see some advantages of it. So the idea here is that it creates a new folder. Let's make one. I'm going to go here to my screen, and I'm going to pull up my Finder window, or your File Explorer on a PC, and I'm going to try and start being organized for this class. So I've got a Finder window. I'm going to briefly close the window while my neighbor cuts the grass, and that'll allow you to open up your Finder window too, or your File Explorer. Excuse me, I'm back. And I'm going to go on my desktop. I'll go to my desktop on my computer. So this is my desktop here. And I've got a folder in here called Courses already that I'll use to organize all my stuff for this course going forward. So I'm going to go Courses. I've actually created one, but let's delete it. And I'll create a new one. So I'm going to make a new folder here. And I'm going to call it BIMM-143 S20. You can just call yours BIMM-143. You don't have to put it in your desktop. I recommend you do put it on your desktop, so we're all in this working in the same place. But if you don't, make sure you remember where it is. So this is just a folder, a place where we're going to organize our hands-on sessions from now on. We're going to store them all in here. Okay, so this is a new folder, and it's empty. If I go in it, you'll see that it's empty. Right, it's just off my desktop. So if I'm showing this another way, here's my desktop, and I've got a folder in here called Courses, and then I've got one called BIMM-143, and it's empty, right? There's nothing in it. Okay, so I'm going to then go back to RStudio here, and where I've been working here in RStudio is if I go back to RStudio here, what happens when I when I quit this thing, where does all the work that I've done and all the figures and the plots and everything go? Well, if I quit this thing, if I click the close icon, or if I go File, Quit, or whatever your shortcut for quit is on your computer, Command Q or Control Q on PC, Command Q on Mac, it'll just go. It's gone. It's away. Nothing's saved, right? There's nothing left for me to revisit the next day. And I can see up here on the very top corner, I'm looking right up above my head here, right up where my mouse is. See in the top window, it says Project None. This thing, I have some things in here, but it's telling me that I'm not in a project. I haven't created a project yet for myself. So I'm going to go and do that. I'm going to say File. So I'm going to say File, New Project. And what this does, so I did File, New Project. Let me make that clear. So up in the top toolbar, File, New Project. I'm going to say New Directory. Directory is just a nerdy way to say folder. It's a Unix speak, because R is a child of the Unix world. So we're going to say New Directory, which is going to create a new folder. And then there's lots of different options here. We're going to ignore them all and just say New Project, the first one. This brings us to another window, and it says, where do you want to put your stuff? Create a project as a subdirectory of. That's the second box here. And it's found it for me already. If you don't have this, you can click the Browse icon and navigate to your desktop, your location where you stored your stuff, the BIMM-143 folder, and say, there, please. And then here, I'm going to call this week. Let's call it week 04. Actually, I'll just call it week rather than. Okay, so week 04. I'll maybe put an underscore in it. Well, I'll keep it. So importantly here, there's a important note. You see the way I've written it all as one word, no spaces in between it, and no spaces here. Spaces we'll see later can cause issues in Unix when we start to learn some command line Unix utility. Spaces are important. So for now, just don't put spaces or funny characters in names and file names or folder names, which is what this is going to create, a new directory. This will create here a directory called week 04 inside the location that I just made, this BIMM-143. Okay, don't worry about these tick boxes. You probably don't have them. We'll set those up at a later time. We're not going to use them for a while. And if I do create project, what's going to happen is our studio underneath is going to go away and come back. And it's a bit too zoomed in. I'm going to zoom out a little bit here. And so it's created a new project, and it started our fresh. Okay, so it's got a brand new fresh instance. See, my environment now is empty. This is all going to be specific for the project. I'm not going to have all those little droppings like my X with, or my Y with those student names and those student grades in them coming along and confusing the work that I'm going to do on gene analysis, right? It's a fresh place that's all stored here. The R brain is focused right in and lives whenever it produces output and things. It's all going to go into this folder, this location, and that's going to save us a lot of heartache later. So we're using these RStudio projects to keep ourselves organized, keep ourselves seeing. Later on you'll see. And then what we can do is we can work in this location. I can open an R script, a little text file to store my work. Right, so let me do that. I'm going to do File again, File, New File, and the top option here is R script. So this is a text file that will open in RStudio. It'll open a little panel up at the top corner here once I finally click on it, and I can put my commands in and it'll store them. And then if I ever want to redo my work, I can just execute that, and I can go have a cup of tea or coffee or whatever more fun thing it is I want to do, and the computer will do all the boring drudgery analysis for me. I can just change the input and it's gone and automated all my work, and that's a big win, right? So let's make one here. So File, New File, R script. What this does is open this new panel. You see the R brain, the R console that we call it, that has kind of squished itself down the bottom. Here you can change the relative sizes of these windows if you wish. I'm just going to leave it squished for now. This is nothing more than a text file. It's called Untitled. You see up here, there's got a little tab is untitled because it's not saved. I'm just going to go and save it. All right, there's a little disk icon here for saving, or you can do Command S or Control S. I'm going to call this week 04.rscript, and I save it. It should appear in this other panel down here, the Files panel. This place, if you notice where it is, it says Home, Desktop, Courses, the BIMM-143 that you said then week 4, and within it I have this week 4 file. It's empty at the minute, but I'm going to put some code in it. Let's do x equals 1 to 50, and let's make our plot of x and then our sine of x, and we'll make it ty equals line. Do LW. You don't have to do all of these arguments, just put some code in here. Line width equals 3, and let's do call equals, let's do red for this one. So here I've got my code, and I can type it and I can push return, but nothing happens, right? There's no plot generated, right? There's nothing. Our brain down here doesn't know about this yet, right? It hasn't executed it down in this terminal. So I can save this. I'm clicking back in my script. I can save it. So it has that content. Now I can see that this little thing ticked up to 55 bytes, right? It was 0 before. Now it's actually got some content in it, this thing. And I can send this to the R brain. There's a number of ways I can do it. I can copy it with my mouse, select it, and do Control C or Command C, and then go down here and just paste it if I wanted to. Click in this window and do Control V. That's kind of convoluted. What I'm going to do is I can also, there's little buttons. You see this source button up here? This will source the contents of the active document. If I click that, I meant to see, I've done a mistake. TYP is what I want. It's a mistake. So there's a mistake in my script. It says this one is an invalid type, so I'm going to do that. So I'm going to source it again, and I get a red plot. It's run the contents. That's that little button here that says source. I could have also just clicked, let's change the color. Let's do green. And I can, if my mouse is on that line, see my mouse is on this line where I've just written green. If I hold Command return, or I think on PC it's Control return, the new line character, it'll just go and paste it into the R brain. I don't have to click any buttons. That's a shortcut. It's like the Command return button. Goes and sends it, and my plot's updated to green. Let's do it again and change the color to purple, for example. Okay, and then I'm holding that Command key, return, and it goes and does it. Okay, so I'm going to save this script. You can add comments in here and say, this is my first R script, and it allows me to store my work, and so it's I'm gonna put a return character here and another one to store my work and automate it later. So I can just run this script and it'll reproduce. Say it was reading in some data rather than doing X here, reading in some data file from a new machine in some company that you're working in or a lab that you're working in, and produce the output. You got it, right? You just run this script. You don't even have to open, we'll see we don't even have to open R in our studio later. You can just execute it and off it goes and makes the output. And that is a big win later when we get into being able to do useful stuff. So let's save that. We've got a new RStudio project for for this week's class. I encourage you to add comments like you're doing here and add your explorations within this. Remember, we were doing together when you're trying out different functions, like let's take the log of X or something like that, and then we can send that down to the R brain by holding Command, turning it, prints it out. Okay. So we can do all those things. One last thing I'll show you. There's a lot of buttons and a lot of features in RStudio. We'll explore them as we get deeper into the course, what a lot of them do. There's one here right in the middle that looks like a little binder. icon. See, it says compile report, and you mouse over it. If I click this, it might ask you to install some software, but what this will do will go off, and it'll actually generate a report with my work in it. All right, like something you would share with. So this is HTML. You can also generate Word and PDF reports, and you could send these to your team or your coworkers or your PI or your boss or whatever, and say, look, I've done all this hard work, this analysis. Really, you've just executed the script again that you had from before, and you've been off doing something more fun or whatever, and you send them a new updated report on the work, right? So we're going to get to all these things. We're going to get to how we generate reports, automated reports, and make them really pretty and change the style and add logos and figures and stuff like that. This one has just the bare bones. It has the code that we used. The output here, like here's the output of the log column 1 to 50 and all the figures. So I think we've covered a lot today, and we've been talking for long enough. I'm going to finish by pointing you to the other big resources that I wanted you to pay attention to this week, which is DataCamp, right? So you all should have got the DataCamp invite. It starts off pretty simple, and bear with it, just suck it up, right? 3 + 4 here is in this first one. We know what it's going to do, but it's walking you through the syntax and getting comfortable and familiar, and then pretty quickly you'll see that we generate useful things. Here's a box plot of some numbers, right, that are quite interesting, that we're going to go and generate these pretty amazing looking figures later on that we could use in a publication, we could use in a scientific manuscript or a report or a presentation. Okay, so stick with it. DataCamp is a great resource. We have access to it for the next 6 months, thankfully. If you're enrolled in the course, they've been very generous in allowing us to have this product. It's used by companies all around the world to onboard staff in the latest and greatest machine learning methods and new techniques, and we're going to use it to try and engage yourselves in this peculiar quarter when we're all working from home, and hopefully it'll give you some feedback and help with your learning. So I'm going to point you to a lot of resources on there and homeworks for each week. Coming forward, we're going to have a different section of DataCamp as homework. And if you have problems with those that you can't immediately address from the help or taking the hint buttons like you'll see as you walk through, just ask us please on Piazza. Ping us, and we'll be very, very happy to help. So with that, I'm going to finish up and say thank you very much for your attention. It's been my pleasure to walk you through this today. I hope that it made sense, and I hope you engage with the DataCamp material to kind of bring this back full circle and start to cement some of this knowledge and get familiar with this syntax. Remember, this is not the most straightforward stuff in the world. It's a new way for us to feel uncomfortable with what we're doing, but together with the support of ourselves and hopefully with your other classmates on Piazza, we'll get through this, and we're going to have great tools that are going to improve the way we work in the future. And this will be valuable whether you stay in science and stay in academia, or you go out to industry, or you do something completely different. This is going to give you a tool set that's going to make you amazingly productive. Okay, with that, I'm going to finish off. I'm going to check one last time if there's any questions here. Aline has answered one from Anonymous Atom. How do you edit and delete an element in a data frame? You can delete rows with the minus. So hopefully Alina's answered that. We're going to learn a lot more about data frames as we go through. We're going to use extra packages to help handling them and things like that. One called dplier. The name comes from like pliers, like electrician's pliers, or that can do all sorts of advanced wrangling. Drop this element, drop that, take this, filter by this, do all sorts of stuff. The stuff that we need to do our bioinformatics, like get to the subset of genes that are associated with this term in the databases, but also have an expression value above this when they're treated with this drug. Those are essentially, what that boils down to is how do you go and extract that column and that row that meet this criteria. That's why we're doing this. That's why we're using X and plotting X and trying to get familiar with X, because when we build up to more complicated things, we'll have that basis to understand what we're doing. Okay. With that, I'm going to finish up and remind you that Alina and Hangxing have office hours at 12:30. That's in an hour's time. And let's go get a break, and we'll see you then. Thanks very much. Bye. If I can turn the thing off. Okay, found it. Bye.